Yeah, good evening, guys. Hello, I'm audible.
Yeah, good evening, sir. Yeah, you are audible.
Okay. Okay, so we'll start the class. Just a minute. Okay, I'll share the screen. Okay, so last class I think we discussed about the task creation. Okay, how to create a task, how to set the priority for each and every task. Okay, and we saw what is an preemption and what is an cooperative method. All these things, right? Today we will see the task control methods. There are multiple methods for controlling your task. Okay, we'll see one by one. Before controlling the task, we will see these two parameters. Okay, what this parameter will do and what is the use of this parameter. Okay, we'll see that. And I'm just closing this project. I'll create a new project. So file stm32. So in the board selector, I'm just selecting it as STM32 F334 as like always. I'm just selecting this board. Okay, so this is I'll give something like an task parameter. Okay. Let it load. I'm just opening this folder. Okay. So I'm not going to do any changes as of now. So first step is I'm going to copy my FreeRTOS kernel folder and I'll paste it here. Okay. So now second step is right click this FreeRTOS kernel properties. I'm going to remove this exclude tick mark. Okay. Apply and close. Sorry. Step number 3, right click the project properties, open the CC++ build and here settings. In that, I'm just going to this compiler include path. I'm adding this FreeRTOS folder workspace, this FreeRTOS kernel. I'm just opening everything. Okay, so mem management, ARM CM4F and include these three folders. I'm just copying. Okay, and these three folders are added. Apply and close. Okay. So now I'm building it. I'll get something like an 4 errors for this multiple declaration. Okay. So for this multiple declaration, what I'm going to do is I'm just going to open the system core. First thing is RCC. I'm just selecting this RCC. Sorry, Maximus. Okay. So I'm just selecting this RCC, high speed oscillator as and bypass, and low speed as the crystal ceramic. Okay. And in systic, I'm selecting an timer 3. And in NVIC, I'm just selecting it as a 4-bit preemption. And code generation, I don't want this system tick timer, pendable request, and system service call. Okay, so I'm just uncheck these 3 things for code generation. So I'm generating it again. Yes, yes. So now what will happen? The code will be generated for the configuration which I have selected. Okay, yes. So done. I'm just building it. So now it is 0 errors and 0 warnings. Okay. So I got 0 errors and 0 warnings. Okay. So this is done. Now I'm just going to open my IETM send car. So I'm just copying this. I'm just going to paste it in the system call.c after this header file. Okay. I'm just copying this ITM send car. I'll put this in the right. Okay. I'm building it again to check this. Right. Okay. So this step is done. This is common for all the projects you are creating in the FreeRTOS file. Okay. Now, so we are going to create two different. We are going to create two different tasks. Okay. Each task will have a different priority or same priority. We will see multiple examples with that, and we are going to pass some arguments to that task. Okay, so that is what we are going to see now. So in order to use an free ATAS, I'm just going to include this as include sorry, as include free ATAS.h. Okay, and then the next one is task.h. I'm going to use an task over here. Okay, so after adding these two, I'm just clicking build and make sure these two header files are added properly. Okay, and then I'm going to create two different tasks. That is, I'm going inside this user code begin 2. Okay, here I'm going to create a task. One is X task create. Task name is I'm just giving something like an task 1. Okay, here I will give something like an okay, I'll just give a task 1. Start depth is 200. Okay, first what we'll do, we will usually give this as a null, and you can give any priority, and this ANDer will also be given as a null, right? Okay, I'm just giving it as it is as of now. And here it is on btask start scheduler. Okay, so I have created two different tasks and I have started the scheduler. Now I need to define what this task has to do. Okay, so this is task number 2. This is task number 2. And let's say this is priority number 2. Okay, so I have created two different tasks with the name of task 1 and task 2. Each has a different priority, and I have started the scheduler. Now I need to define what this task has to do. Okay, so for that, what I'm doing is I'm just directly going to this user code 4 here. I'm just creating void task number 1. Inside this, I'm just giving an void pointer. Okay, so inside I'll give an while of 1. I'm just going to give a printf statement with this is task number 1 /r/n. Okay, and similarly the same thing I'm just going it for task number 2 also. Okay, so this is task number 2, task, all these things. So I'm just copying this in order to define this on the top. So I'll just directly go to private function prototype over here. I'm just going to declare this function. Okay, so task number one and task number two. That's it. So this program we have already seen in our last class itself, creating two different tasks with two different priorities, and we are going to print something inside a printer statement. Okay, so that is as simple as that. Okay, I'm just building the code, showing some warning because of the stdio.h. So I'll just give hash include stdio.h. Okay, I'm building it. Okay, now it is zero errors and zero warnings. So if I connect my board and run it, what I will get this task number one that will be repeatedly printing because it has a highest priority. Okay, now instead of printing this in the double quotes, for example, you are getting a value from the sensor. Okay, and you are storing that value in a variable and you want to print that value over here. Let's assume like that. So what you will do, you can't directly put something inside a double quotes, right? So we need to pass something as an argument from outside of this task number one, because we are going to get an sensor value in a different task and you are going to print that value in a different task. Let's assume like that. So that is very difficult if you are giving it in the printf statement, right? So we need to do something else in order to print the value uh, in the printf statement. Okay, so for that, what I'm going to do, this fourth parameter. Okay, over here, whenever you are creating a task, this parameter is an argument for this function. Okay, if you want to pass any arguments, you will be giving this in this fourth parameter. Okay, now there are two methods of passing this argument, right? Before seeing this, I'll just show you what this output is. Let's see comes and then we will do the changes so that you can able to see what is happening. So build, I think that's done. Right click, debug as STM32. Okay. So debugger, I'm just going to enable the serial wire viewer. Okay. So switch. Okay, so now we are inside the debug mode. I'm going to open this data console, config port number 0. Okay. And I'm just going to enable this trace. And then I'm just going to start this. This is task number one that will be printing because task number one has an highest priority. Obviously, that has to be printed. Okay. Now, instead of printing it inside a double quotes over here, what I'm going to do, I'm just going to transfer that statement in this argument column. Okay. So there are two methods for doing that. One is we can directly put this inside the double quotes. Okay, that is a string only, right? So I'm just going to directly put this. This is from argument. Okay, I'm just giving something like that, right? So where I have given it, I have given this in the task number one, right? So I'm just directly going to this task number one. Now, when this task number one is called, the value or the argument will be passed to this pointer P. Okay, because this is what your function argument is. So your pointer P now holds the string, whatever the string we have given over here. That is, this is from the argument. Okay, so that string is actually passed and it is stored in this P. Okay, now I want to print this void pointer. Okay, so you know what is void pointer, right? I think you people have studied this in the C program itself. What is void pointer?
Pointer which can carry any type of data.
Yeah.
It
So
is.
this void pointer, it doesn't have any data types. Okay, you can actually store any data types. Okay, it can be an integer, or it can be a float, or it can be character, whatever it is. It can store all the type of data types. That is a void pointer. Okay, now this void pointer actually holds that string. Now here I'm just going to print a string, right? So I'm just putting percentage yes. Okay, for printing. This is your normal C program, right? Here I'm going to print this P. Okay, that is the pointer P. Now, since this pointer P is a void pointer, I'm going to print a character over here, or let's say a string over here. Okay, I need to convert this void pointer into a character pointer. Okay, we call that as a typecasting. So if you want to print an integer value, then typecast it into an integer. Okay, so I'm just going to type character pointer. Okay, of this P. Okay, so now what will happen? The string which we have passed in that argument, that will be stored in the P. Okay, and that I'm going to typecast into a character pointer, and I'm just printing it over here. Okay, so that is what uh, this is. Okay, this is the first method. First method of transferring an string or any data as an argument whenever we are creating a task. Okay, so we'll see what output we are getting for this one. Okay, so I'm just going to press STM data console. I think it is already enabled. So I'm just clicking. Okay, so it is printing. This is argument. This is argument. But since we haven't given any slash n slash r, this is printing in the group. So what I'm going to do, I'm just going to put n slash r slash n. Okay, here, or you can directly put a slash r slash n over here itself. Okay, so any method is fine, since that is also considered as a character, right? Sorry, that is also considered as a character. We can directly put it over there, or you can put it inside a printf double quotes. Okay, so I'm just going to rebuild it again. Switch data console, and I'm just resuming it. Okay, now we can say this is from argument. This is from, since it has an highest priority. Okay, that is printing. This is from argument. This is from argument. All these things. Okay. So instead of printing the value from the task, I'm actually giving this inside this double quotes. Okay. While creating a task itself, whatever has to be printed, and that can be passed as an argument to this task or the function, and we can print it over there. That is step R. I'll call it as a method number one. Okay. Now method number two is, this is actually similar to the what we are giving in the printf statement, right? Okay, that is same. Instead of putting here in the double quotes, I can put that on the printf itself, right? So what is the difference between putting it here and there? There is no difference. Okay. Now instead of giving this in the double quotes over here, second method, I'm just going to create a private variable which is called as character, let's say um, text. Okay, so I'm just going to give this is from variable. I'm just giving something like that. Okay, and just put it in as an array. Okay, so I'm just giving this is from variable. Okay, now I'm just giving here. So what is the variable name? The variable name is text, right? So I'm just giving, since it has an character array. Okay, I'm just going to pass the address of text over here. Okay, because my function argument is a void pointer. Okay, so I need to pass an address for that pointer. Okay, so here I am passing this variable as an argument, and inside this task number two, here instead of this, I'm just directly giving percentage yes. Okay, and then here the same thing. So I'm just going to convert this into a character pointer. Since it is an void pointer, I'll just print it as a p. Okay. Now, in order to print both these values, I'm just going to give something like an v task delay. Okay, so I'm just giving something like an 500 because I want to see both the functions. So I'm just giving here also 500. So I'm just building it. Now I'll just debug. Switch. Okay, SVM data console. I'm just resuming it. Now you can see this is from argument, this is from variable, this is from argument, this is from variable. Okay, so instead of printing that in the printf statement, I'm actually doing two methods. One is I'm just passing it as an argument. Okay, and I'm printing it in the task number one, or I'm just passing it as a variable and then I'm just printing it over there. Okay, so both these things are possible, right? So this is how we'll be using this fourth argument as a parameter to this function, whichever we are creating. Okay, clear? Any doubts?
Yes.
Okay, so copy this one. So first give these three header files and then let me know once you finish this. I'll just scroll down.
Sir, it somewhat looks like creating a threads and process.
Yeah, that's what I already said, right? Since it is in parallel processing or multi-threading, okay, your entire FreeRTOS is made up of a multi-threading concept only.
Okay, okay.
Yeah.
Because I'm working in that only. That's what.
Okay, okay. Please scroll down. Finish this. Guys, finished?
Yes.
Okay. Do I need to scroll down or shall we go to next pro? Everyone? Shall I go to next problem? I mean, next program, or do you want to finish this task 1 and task 2? Are you getting output? Anyone?
Sir, you can go for next.
Yes, sir. I'm getting. Okay.
Okay. Okay. Okay. So the next project is something similar to that of this, the last one. Okay. So this last parameter is like we call it as an handle, as like how we have an handle for the timers in our device driver, the ADC handle, okay, and UART handle, all these things. We are going to create an handle for our task. Okay. So based on this handle, or by using this handle, we are going to do some different task control things. Okay. So that is what we are going to see as the next project. Okay. So that is in task control. So how we are going to control this task. Okay. So there are multiple APIs available for controlling the task. We'll see one by one. So I'm going to create a new project with the name of task control. Okay, so this is task control. I'm just going to do the same steps again, since we already know that, and I'll just do this fast. Explore. I'm going to do this with add workspace, task control. Okay, I'll just close this one. Okay, done. So these steps we already know are the same configuration steps. Okay, so I'm just going to create again the same thing, like a two different task within same or a different period. That is your wish. You can give anything. It's not going to affect anything over here. Okay. So here in the user code 2, I'm just going to create X task create of first one is I'm just giving something like in function 1. Okay. And here I'm just giving it as a task number 1, and depth is 200, and this is what I will do. Okay, I'm just going to create a two different parameters. Since we already created it, we will just start using it in our all the programs. Okay, so first one, I'm just going to give some character, something like in capital T1, which is equal to Okay, I'll print it as something like an LED one on, and similarly for this LED two on. Let's say this is T2. Okay. So here I'm just going to pass these two arguments. First one, I'm just going to pass it as an T1. Okay. And the priority, I'm just giving it as an 3. And as of now, I'm just giving it as a null. Okay. I'll tell you what this one is. So here also, this is same thing like an function 2. And this is my task number 2. Here instead of T1, I'm just going to pass T2 as an argument. Okay, let's keep it as a same priority. Or if you want to give a different priority, there is no issues. That is not going to affect anything in this program. So I'm just giving it as an task vtask. Oh, sorry, start scheduler. Okay. So I've created two different tasks with an parameter. Okay, for both the task and priorities as the same for both the task, and I have started the scheduler. Okay, now I'll create an function for these two, function 1 and function 2. Okay, so that I'm going to do in the user code begin for void function 1. Inside this, I'm just going to give an void pointer. Okay, now inside this, we will have an infinite loop while of 1. Okay, now inside this while of 1, I'm just going to put an printf statement of percentage yes. I'm going to what we will do. Okay, I'm just going to pass this as an character pointer with this p. Okay, so let's make this as an start new row and new column. Since it has the same priority, I just need to do something to switch between multiple tasks, right? Okay, properly. So I'm just giving it as an v task delay. Okay, so I'm just giving it as a 500 millisecond delay for switching between these two tasks. Right. So here this is function number 2, and here the same thing. Okay, I'm not going to change anything since this name is also p. It will work with a p. Okay, the only thing is the argument which I am passing while creating, that is going to be different. Okay, everything else is same. Now I just need to declare this on the top. So I'll just directly go to this private function prototype, and I will just declare these two functions. That's it. So this is our previous program. So I have given an argument while creating the task, and that argument has to be printed inside the printf statement of these individual tasks. Okay. Now the last parameter over here, as I already said, it is an handler. Okay, if you want to handle this task, not this function. Okay, so there is a difference between this function and the task. Okay, function is nothing but what this task is going to do. That is what this function is. Okay, whatever the name you are giving, whatever the operations you are performing inside it, that is what this task has to do. Okay, but on whole, there is a name for this task. Okay, that is the handler. Okay, if you want to do anything for this entire task, like if you want to change the memory, or if you want to clear the memory, okay, or if you want to change the priority, right, or if you want to see something like an which task is currently executing, all these things can be done by using this handler. Okay, that is what the last parameter, sixth parameter is. Now if you want to give the handler over here, we need to declare an variable as like how we did for T1 and T2. But T1 and T2 are variable that is going to get the string. So I have given it as a character array. Okay, but here this is an handle, right? Okay, so for that I need to declare that variable itself as an handle. So I'm just giving task handle underscore t. Okay. In that, I'm just giving a name for this task. Okay, you can give any name, that is your wish. There is no restriction. The only thing is this handle name, what you are going to give, should not match with this function name. Okay. For example, here, if you are given something like a task one, this handle name should not be task one. Okay, it should be different. That is the only restriction. Otherwise, you can give any name for that. There is no issues. So since I have given there as an function one, here I'm just giving it as a task number one. Okay. And similarly, here I'm just giving it as task number two. So I'm just creating two different handle. One handle name is task number one. The other handle name is task number two. Okay. So the data type or this has to be something like, and the structure name has to be task handle. Okay. Now I need to use or assign these names inside this task. Okay. So that is the last parameter. Here I'm just going to give it as an ampersand task number one. Okay. So now the name of this entire task is task number one. Okay. The function name of this task is function number one. But the handle name of this task is task number one. There is a difference between these two. Okay, don't confuse that. And this is task number two. Okay, so I have assigned a name for both these tasks. One is task number one for the first task and task number two for the second task. Okay, and the function name is function number one and function number two respectively. Now, what is the use of this handle? Means we can actually be able to do multiple things with this handle. Okay, we will see one by one. The first thing is there is something called as a task suspend. Okay, so we have seen that from the beginning, right? There is something API which is available for suspending the task. Okay, so we are going to suspend the task. Like you can see over here, there is something called as a task control, right? If you open it, okay, you can actually use all these things, okay, inside your program for controlling your task. Okay, the only thing is you just need to give where it is. Okay, for example, if it is a task suspend, okay, you can see void task suspend. Inside it is asking an argument or a parameter like which task has to be suspended, and that task name has to be task handle. Okay, so that is why we are actually giving a task handle name for this task whenever we are creating. Okay, that name has to be given over here whenever you are suspending a task. For example, if you want to resume the task suspended, then you just have to give something like this, the same task handle name, which task has to be suspended. Okay, and for example, if you want to set the priority during runtime, you just have to give which task and what is the priority, something like this. Okay, there are multiple ways of using this handle in our program. We will see one by one. First one, we'll see this suspend. Okay, now inside this function, first I will run this program and I'll show you what output we are getting, and this is for the stdio.h. Just keep on forwarding it. Okay, so I'm just giving stdio.h and I'm building it. Okay, so if I debug, I'll just right click debug as stm32. And inside this debugger, I'm just going to enable the serial while viewer and click OK. Now it will go to the debugging mode, switch. Okay. Now we are inside this debugging mode. I'm just giving this data console with then port 0 and I'm starting the trace. So when I click resume, you can see LED2, LED1, LED2, LED1, LED2, LED1. Okay, that will be keep on printing because both this has a same priority and also I'm just giving a same VTask delay for this. Okay, so that's why it is printing for every 500 millisecond, both this task, right? Now I want to suspend this task. Okay, so I'm just going to give instead of this v task delay, what I will do, I'm just going to give v task suspend. Okay. Now there is two APIs. One is vtask suspend of a particular task, or there is something called as an vtask suspend all. That means all the tasks will be suspended. If there is any, let's say there is any high priority task comes, or if there is any emergency shutdown has to be performed, and if you don't want to perform any task during that time, then you can suspend all the task. Okay, so we can use that vtask suspend all during that time. Okay, here we are going to suspend a specific task, right? Now, inside this, it is asking which task I need to suspend. Okay, I don't know whether you remember this from our first class of this, I think second class I have given this diagram, right? Where it is, yeah, this one. Okay, you can see this suspend task, you can go from any task. You can go from ready task to suspend task, or whether it is running, you can go to suspend, or if it is blocked, you can go for suspend. Okay, you can go from any of this task to the suspend task. Okay, that is the thing by simply giving this v task suspend thing. Okay, now when I give this v task suspend, it is asking whether I need to suspend task number one, which is currently running, or task number two, which is currently in the ready state. Okay, so as I already said, you can move this task from any of the state, right? I want to suspend my current task. What's the name of current task? My current task name is task number one, right? So I'm just going to give task number one, I need to suspend like this. Okay, so previously you have seen the output, right? What is an output? I just got something like an LED1, LED2, LED1, LED2, all these things has been printing. Okay, now you can see I have suspended this task. Okay, that is this task number one. Okay, now you can see the difference in output. Switch. Now, if I click resume, and okay, that's enough. I'll just copy and paste it in the notepad. You can see first LED2 is on, then LED1 is on for only one time. After that, it is in a suspended mode. Okay, so only this LED2 is keep on running. Okay, even though this task number two, that is this function number two, even it is having a vtask delay. What is mean by vtask delay? That means I am telling my scheduler that I need in 500 milliseconds so you can execute some other task. That's what this vtask delay, right? Even though I have given this vtask delay of 500 milliseconds, this task will never get executed because I have moved this task to the suspended state. Okay, so this suspended state, as I already mentioned, it is a permanent state. Unless until you are resuming it back, it will never print. Okay, or it will never be executed. That is what a suspended task is. You can manually move any task to the suspended task. Once it is moved, unless until you are giving an resume, you will never get this output. Okay. Now what I will do, I'm just going to do something. Okay, let's say I'm just going to create something like an int. Okay, I'll just declare this in the private variable. Okay, I'm just going to give int count equal to 0. Okay, so this is unsigned integer, right? Now, each and every time this is executing, I'll just make this vtas delay. Each and every time it is executing, I'm just giving a count plus plus. Okay, if my count is greater than something like 20, I'm just going to suspend this task. Okay, I want this task to be executed for only 20 times. After 20 times, this task has to be suspended. That's what I have given. So each and every time this function one is executing, this count will be incremented. And when it reaches 20, I'm just, suspend this task. And what we will do, okay, let's say first we will do this one. So I'm just debugging it. Switch. And here, when I click this resume, I'll just let it go for something like, okay, so now only LED2 is blinking. Okay, I'm just copying it and I'll paste it in this notepad. Okay, you can see initially this LED one has been frequently switching, okay, for 20 times. So 1, 2, like 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then this is 13, 14, 15, 16, 17, 18, 19. Yeah, it's less than 20, right? So it is 0 to 19. So it has been executed for 20 times. And then you can see only this LED2 has been executed. Okay. So you can give something like if you want to execute a particular task for some amount of time, after that it should not been considered for execution, then you can give something like this. Okay, this task has to be executed for only 5 times or 10 times. After that, it should not execute, something like that you can give. Or you can execute this periodically. Okay, so that you can able to give something like okay, what we will do is, let's say here, if it is 20, okay, I'll do one thing. In this function number one, I'm just making it as an high priority, and function number two, I'm just making it as a low priority. Okay. Now, if I execute, only this function number one will get execute, right? Because since it has an high priority, it will execute for 20 times. After that, it will stop. Okay. So none of the program will be executed. Okay. Now, I want this has to be printed for again something like a 20 times, and then it has to come back again. Okay. What should I do? Now we know this function number one will execute for 20 times. Okay, fine. I want this function number two also to be executed for 20 times. After that, function number one has to be executed again for 20 times. What should I do? There are multiple ways for doing this, but I just want the best method or the easiest method. Can anyone tell? This task number one will execute for 20 times. Okay. After this, task number two, that will be executing continuously. But I don't want this to be continuously executing. Instead, I want this also to be executed 20 times. After that, it has to again switch back to function number one, since function number one has an high priority. Now tell me what to do.
The first task number one will execute, right?
Yeah.
Okay. Then, like for 20
Okay,
times.
I'm just removing this task delay. Okay, so that it will never go to task number two. Okay.
Now it will execute for 20 times.
Yeah, 20 times. Then suspended.
Yeah.
It will go to function number two.
Hmm.
Hmm.
Then we need to execute this for 20 times, right?
Yes, yes.
Okay. Again, here we have to add one more count.
Okay, we need to declare one more count.
Yes.
Okay, let's say count one.
So, yeah.
and then I need to put a plus plus, and if the count one is again greater than 20, I need to suspend this also.
Yeah, then we put if condition
Okay.
and suspend. Then for removing suspension, we have to give one more statement.
Yeah, that is resume.
Yeah.
Okay, we'll resume the function number one.
Mm.
Okay. Okay. Fine. Who said that?
Me, Mohammed.
Okay. Yeah. Any other method? Arvind, Augustine, Yogesh. Okay, this is right only. Okay, I'm not saying this is wrong. This is right, but there is another method also. There are multiple methods of doing this. Okay. Any other methods? Okay, I'll just type what Mohammed has said. He said that we need to create one more variable called as count. This is
Or we
count
can
number.
decrement that one, that old previous one only.
Yeah. So that is an easiest method or a more efficient method. Okay. I'll just do both the steps. First is count number one. So inside this function two, I just need to remove this one. I'll just put count one plus plus. Okay. After that, if this count one is greater than 20, then again same thing, like I need to suspend the task number two. Okay, suspend task number two, and I'm just going to resume. Okay, so there is another API that is called as a vtask resume. So whenever we are suspending any task, this or a resume API is going to get it back to the ready state, not in the running state. It will just get it to the ready state. Okay, and your scheduler is the one who has to pick whether it has to be executed or not based on the priority, right? So I just need to resume task number one, which is already suspended over here. Okay, and similarly, I just need to give the same thing for this task number one. I'll just put it over here. So this is, let's say this is task number two. Okay. So this is one method. Okay. Or what we'll do is I'm not going to use any variable here. Instead, let's say, instead in this private variable, I'm just where it is. This count number one, I'm just going to delete it. I'll use only one. Okay. This count is now 20, right? Okay. Once it reaches 20, it will just suspend and it will come out. Okay. Now what I'm going to do here, I'm just going to make this count minus minus. Okay. And if this count is something like greater than 0. Okay.
We can put if
Sorry.
um,
Less than, yeah,
not equal.
not equal.
Sorry, that not operated before. Sorry.
Where?
Okay.
No, just tell. It's your suggestion, right? See, I always tell this to any programmer, like there is no such thing called only one way of writing a program. Okay, if there is 100 people present in a room, 100 different programs can be written for the same output, same input. Okay. Yeah. Okay. What is your suggestion? Where I need to put out, not. Getting this. Okay, where I need to put not.
No, sir, I confuse. You can.
Okay. So I'm just decrementing it over here. So if this count is less than 0, or I'll just put less than or equal to 0, then this task will get resume. Okay, instead of suspend, I'm just giving it as a resume. Okay, now what will happen? Since the task one has an highest priority, your scheduler will always pick this task number 1 and it will start executing. Okay, since it is available in the ready state, so that will be keep on executing. So again, this count will be incremented to 20 and then it will suspend, it will come again it will be reducing. Once it reaches 0, again it will do, so it will be keep on happening for 20 times. Hopefully we will just check it whether we are getting. I'm just giving switch. Okay, now resume with this SVM data console. Okay, I think we are getting an output properly. I think so. Okay, so first my LED 1, I think it is on for 20 times. So it is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, and then again it is 2, 4, 6, 8, 10, 12, 14, 16, 18. I think it is printing more than 20 times. No, I'll just do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 20, 21. Okay, it is printing 21 times since I have given less than or equal to. Okay, so this is 20 times. Again, this is 20 times. Again, this is 20 times. Okay, so if you want to execute any task periodically, then you can give something like that. You can resume any task. You can, you know, suspend any task at any given time. Okay, so APIs which we are going to use is vtask suspend for suspending a task, and you need to give this handle name. Okay, like what we have created over here. This is the name for your task. We need to give that particular handle name as to be suspended or has to be resumed. Okay, if both the both the priority is same, then what Mohammed has said, that is the method. That is the only method we need to do. Okay, we need to suspend one task and resume another task in one thing, and again the same thing in another task. We just need to suspend and resume the other task. Okay, if the priority is same. If the priority is differ and something has an higher priority, then you can use this method. Okay, so that is depends on the priority. You can write this function 1 and function 2. Okay, so these things are same, and just directly go to the function 1 and function 2. Just do this one. Okay, write it.
Sir, in this code there is one while loop, no? Like before, like what where we are writing that bare metal code.
Yeah.
So that while loop is not executing here, no?
No. Once the scheduler comes, okay, it will
Okay.
just take care of all this priority based execution. Okay, it will never go to this while of one.
Okay.
Yeah.
Sir, that function one, the function. Sir, scroll down. Sir, done, sir.
Okay, others? Are you getting output?
Yeah, I'm writing so the function.
Okay, okay.
I done, sir.
Okay. So others. Okay, so then we'll see the next example, which is something similar to that of the Vita suspend. Um, we can actually be able to change the priority of any task during runtime. Okay, so we have an API for that. That is a vtask set priority, or I think vtask priority set. Okay, so we can able to change the priority of any task during the runtime. We can able to increase the priority, or we can able to decrease the priority. Okay, so that is our next program. We will see that. So that is the last thing in our task control. So next is task priority set. Okay, I'll just give like this. Okay. Just a minute. Sorry. So just do the same thing. Paste. So I hope you are familiarized with the steps since we have created something like 5 to 6 projects as of now. So I hope you are familiar with these steps. Task priority set. And folder. Okay, it's already there. Include memory management and one more folder. Same. Okay. Done. Then system core, RCC, bypass, and crystal ceramic. Timer 3. Code generation. System tick. Okay, so 0 errors and warning. And so I'm just going to copy and paste this ITM code. Step. For sources is called paste ITM simple type function. Okay, so build. I'm just going to close this other project. Okay, so now what we are going to do, I'm just going to create a 2 different task as like before. Sorry. So here X task create. Let's say this is task number 1 and name I'm just giving it as something like okay, I'll just put it as an I priority. Okay, and this is 200 parameter. I'm not going to pass. We know already what to do. So priority, I'm just setting it as a 3. Okay, and handle, I need to create an handle. So here private, I'm just going to give task handle underscore T. I'm just giving something like an capital T1, and again one more task handle. Okay, so I'm just giving a T2. So 2 different tasks, T1 and T2. So since my function name is task1, I'm not giving the same name again. Okay, so I'm just giving in something like an T1 for the handle name, and similarly other handle name is a T2. Okay, for task number 2. So here it is task number 2. Let's say it has a low priority. Okay, I'm giving something like a 2 for T2. Okay, after that I'm just starting my scheduler. So this is v task start scheduler. Okay. Now I need to create a function for this task 1 and task 2. So I'm just directly going to this user code 4, and I'll just create and void task number 1 of let's say void pointer. Okay, so inside this I'm just giving a while of 1. So inside this while of 1 I'm just going to put printf. This is okay, I'll just put a task number 1 in bracket. I'm just putting it as an high priority. Okay, we just need to know this is high priority by default. Okay, I'm not giving any vtask delay or anything. I'll just do the same thing for task number 2, and I'm just giving this as a task number 2 with low priority. Okay, and I just need to declare this function. So I'm just directly going to this private function prototype. Here I will just declare these two functions, task number 1 and task number 2. So I'll just build it. Okay, there are some 3 different warnings. Okay, I didn't give this free RTOS over here. So as include free RTOS.h, again as include task.h, and as include stdio.h. Okay, so I'll just build this. Okay, now 0 errors and warning. Okay, so now if I execute this, what will happen? Only this task number 1, that is, this is task number 1 high priority, will get executed because since it has an highest priority. Okay, now what I'm going to do, I'll just do the same thing as like what we did before in our program. I'm just going to create an unsigned int. Okay, count. I'm just going to make it as a 0. Okay, I'm going to use this count program. So here I'm just going to increase my count plus plus. Okay, if let's say my count is greater than something like an 500. Okay, since I didn't give you any vtask delay, this will execute fast. Okay, so that's why I'm just giving an large number over here instead of 10, 20, something like that. Even you can give something like in 5,000 also, there is no issues. I'm just giving something like 1,000, sorry, 500. So if count is greater than 500, what should I do? Okay, I just need to change the priority. So now this is then high priority task. Okay, right? Now I need to change. Okay, first we will see what will happen with this. Okay, I'm just building this. We'll see what is the output we are getting. After that, I will show you the different output, what has to be get. Okay, so debug serial wire viewer. Okay. So when I click resume, you can see only this task number 1 that will be keep on printing. Okay, since it has an highest priority and we didn't give any functions for switching like and suspend or a vtask delay, we didn't give anything. So this high priority task will keep on executing. Okay, now what I will do, I'm just going to terminate the session. Here in task number 1, okay, if my count is greater than 500, okay, so there is something called as an priority set. Okay, we can actually able to change the priority of any task. Either it is a current running task or the task which is in the ready state. You can change the priority of any task. Okay, so I'm just going to give v task priority set. Okay, it will ask two parameters: which task I need to set the priority and what is the new priority. Okay, whether I'm going to set the priority for the task which is currently executing, that is T1, or the task which is available in the ready state, that is T2. Okay, so I'm going to change the T2 task, and the new priority is, my current priority is actually 2 and 3, right? So this priority is 2 for the task number 2, that is T2. Okay, now I'm going to change the priority of that into 4. Okay, now what will happen? Your scheduler will sense, okay, there is a priority which is higher than the current running task. So I need to execute that first. Okay, so now this task will be put to the block state and this task will be executed. Even though it has a low priority by default we have created, during runtime, we can actually able to change the priority of any task by using this priority set. Okay, so I'm just going to debug it. So switch. Okay, so we are inside a debug mode. I'm just going to click resume. Stop. Okay, now I'll just copy this and I'll paste it in the notepad. Not there. Okay. So you can see over here, initially my task number 1 is executing since it has an highest priority. Okay, I'll just scroll down. Okay. Drag this one. Okay, so this will be executing for 500 ticks. Okay, so that is why it is not a count of 500, it is 500 ticks. Okay, if your task is executing more than 500, then that is also fine. It is not always each task has to be executed in a single tick, not like that. Okay, now after this 500 ticks, what is happening? Oh, we are given count, right? Okay, if it is a count, then it will be 500 task. Okay, after this, what is happening? This task number 2 that is executing, since it has an highest priority. Now we set this during the runtime. Okay, now this task will be keep on executing. We didn't suspend task number 1. We didn't delete the task number 1, or we didn't put any delay for task number 1. We just changed the priority of task number 2 as an highest priority. Okay, so now this is actually executing by preempted this task number 1. Okay, so that is what happening. You can able to set the priority of any task during runtime by using this API, which is called as an vtask priority set. Okay, so remember that one. We have one API for changing this. Okay, instead of no, actually you can set the priority load also. Okay, you can try this like what we did in our previous example. Just put a count minus minus over here and make it something like, and if it is less than or equal to 0. Okay, and make this priority as something like T2 priority, right? So T2 priority, again make it to 2. Okay, so that again this T1 will be executing for 500 times, then this T2 will be executing for 500 times. Okay, so that is what will happen. Okay, you can even increase the priority or decrease the priority. You can set any new priority for any task. Okay, here we set the ready state task, here we have set the running state task. Okay, so that is the task priority. Okay, so is it clear? Any doubts?
Clear, sir.
Okay, so there is one more thing I just want to discuss. If you see the APIs in our FreeRTOS, okay, some of the APIs are started with X, okay, and some of the APIs are started with V. Okay, you can see task creation and For timer creation, we will see that in our next class. Okay, so timer creation, queue creation, okay, queue send, all these things will have something like an X. Okay, X queue send, X queue receive, X timer start, X timer create, X timer stop. Okay, there are some APIs in FreeRTOS starting with X, and there are some APIs in FreeRTOS that is started with V. Okay, the difference between V and X is V means void. Okay, void, V void, void. That means this API is not going to return anything. Okay, that is what an void is. If you have this priority set, this will not return anything. Okay, but your X task create will return something like an hello. Okay, there is no hello over here, right? So there is something called as a null. Okay, if you go to this API page, okay, task creation, right? You can see over here. Yeah. So if the task was created successfully, okay, why the task will not create means we are asking to get something like a 200 word length, right? Let's say you are creating some 10 different tasks and your memory is full. And if you are trying to create a 11th task, if there is no memory, your task will not get created. Okay. So if the task was created successfully, it will return PD pass. Okay. And if the task couldn't able to create, then it will return something like an error could not allocate required memory. That will be written. Okay, so whichever task has a X in front of that, that is going to return something, whether it is an PD pass or a PD true, okay, something like that, or it will return something like an error could not allocate memory or null, okay, or PD false, something like that, right? So that is what this X started API is going to do, and V started API is not going to return anything. Whether it is done or not, we don't know. We just have to assume it is going to work. That's it. Okay, so that is not going to return anything. So that is what the difference between X and V. Okay, and that is one of the interview question also in FreeRTOS. What is the meaning between this X started API and V started API? Okay, yeah. So copy this code. I think this one you already know. So I'm just directly going to this task number one. If you want, I'll just scroll up to this task creation also.
Sir, when I'm pressing Control plus space, it is not coming. That suggestion will come now.
Okay. So after giving this header file,
Hmm.
either save this or build it so that it will be added in this main.c.
Yeah.
Okay, if it is not added, you will not get this control space.
So can you show the task creation and task scheduler? Okay, sir. Sir, scroll down, sir. Sir, done, sir.
Okay, got output.
Sir, actually, I missed that configuration. that I'm
Oh,
doing.
okay, okay, okay. No. Yeah, so this is the task control. Okay, so tomorrow we will see um, queue timer. Okay, so tomorrow we'll see the timers. Okay, so how to create a timer in free ATAS. Okay, that we will see tomorrow. Okay, yeah. So thank you. Bye. We'll see you tomorrow.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Yeah, thank you. Bye.